Okay, today we're going to talk about some BabylonJS playground features. I've been using the BabylonJS playground for a while now for iterating and proving out concepts for my game, and I think it's a great system that they got going on here. We got code on one side and BabylonJS output and the scene on the other side. One of the frustrations I had with that was how large my modules were getting, because it was just one file, and finding where I was in my place and skipping back and forth within that one file. So I wanted to extend the functionality here. And what I did, this is a proof of concept that I have from my BJS fork that's currently deployed at playgroundv2.versal.app. So what I did was implement multiple files here. So these are JSTS modules, and they provide local file or local module exports and imports. So we have multi-file support with tabs here. And the way that's eventually run is each module gets turned into an ES module in the browser. So it's debuggable. We'll get into that here in a little bit. It's got support for NPM modules. So these are third-party libraries that people publish. It's a very common way to develop any kind of JavaScript, TypeScript project is to rely on some type of library that somebody else has written. So some Monaco, that's the code editor, some quality of life things with declarations and being able to follow links and go back and forth. And for the future, got some ideas for what could plug in here to be a next level kind of, I want to use this and integrate with my BJS workflow. But for now, I just want to start off by creating a new file. So we'll create new.ts, and anyone familiar with the syntax here, this is pretty common for the last 10 years or so. I'm just going to create an object and export it. And I'll give my string, and this is all TypeScript syntax, but it takes JS as well. I don't really need to definitely type these. So this is a very plain object I have here from new.ts over in this file. There's a couple different ways I can do this. I'm going to do a star import, which imports everything all at once. And I'm going to pull it in from new here. And if I look at obj dot, I have my object dot a dot b. So it has IntelliSense here in this file. And if I were to command or control click on here, it will immediately go to the file and open it up. And if I were to say I have A right here and I click on this, then it'll give me a definition of this here inline. So I have my object, and let's make sure that it's actually working. So I'm going to put a console log in here. That's the foundational element for any kind of debugging. My object value is going to be obj.myObject.a. Let's run that. My object value is my string, so that is correct. It's working here. And while I have this open, I want to kind of illustrate how this is now compiled and put into the browser. So each of these tabs right here is compiled as an ES module with source maps if you're using TypeScript. And they come up here under the source registry under file pg index. And you see this is my code right here. So it's not just a big block of string text. Previously you could do that in the current playground just by putting a debugger statement in there, but it's going to hit it every single time. And there's no way to optionally set a breakpoint the way there is in Chrome Dev tools with a conditional breakpoint or log points, whatever you want to do here. So as long as things haven't changed here, I can run here and I can set a breakpoint, and it's a fully fledged module that I'm looking at. So I can do all sorts of introspection on the whole thing. I can set breakpoints and the whole gamut of everything to do with debugging. And if I wanted to change a value here, another console output, and run this here. If I had a debug breakpoint, that would have gotten cleared, but we see that this automatically updates here, and then I can set a new breakpoint and hit that with my new line here as well. So that's our relative imports right here. We can have as many as we want. They're all up here in the top. There isn't something as sophisticated as a file directory system like VS Code or anything. This is kind of just first pass here. So we have, you know, you can create as many modules as you want, and once you reach a certain limit, then a scroll bar will appear here. You'll be able to scroll back and forth. Should look good on mobile as well. But yeah, this is just kind of the start. So next up is the NPM module support. Say I want to use some Lodash features for anybody using Lodash in 2025. So I can just type in the NPM name right here of Lodash. I can take a look, and it's got automatic type acquisition. That means anything I'm loading from NPM will automatically load in the types for IntelliSense and for source maps as well. So it depends on the module that you're trying to pull in, what kind of support that's going to have all around. It's not going to be consistent across every single package. These are third-party libraries. Everybody publishes a little bit differently. But in this case, I have full type support over all the different overloads of lodash.get. So this function from Lodash looks at an object and takes a property path and then gets the value from it. So I'm going to do value equals lodash.get, and I'm going to put in my object here. And we're going to put in the path A, and it thinks it knows about that already. I'm not sure where that IntelliSense came from. It's pretty cool though. Okay, let's see if it gets it from Lodash here. Got value my string. Great. And I can also put a breakpoint on here, and actually I want to keep going. This one here, and I want to actually see if I can step into the Lodash get function. Yep. And all this stuff that I'm loading from NPM is also loaded in the browser through esm.sh. So I can step through library code as well. So this is external library code. It's in here. It's not like faked out or anything. This is the real library, and I can step however deep I want. So if I'm depending on third parties in my actual project and I want to pull them here, and the playground is a proof of concept, I can pull them in and use the exact same thing that I'm using in production for whatever I'm working on in BJS. So I think I've gone through this a little bit, but we have declarations here like this. This will go right to the get and give all the definitions of get. For my object, we can link here, and there's navigation going back and forth. There are some much more complicated examples I have set up that I'm going to cover probably in another video for another purpose. But for all intents and purposes for this one now, I would say that this about covers it. So the main takeaways are that we have multiple file support with tabs. I'll create a new one here. And there's also support for shader code and FX. And don't really have time to run through that one now, but that is supported as well. That will import through a raw string. And what I'm hoping is to just give a brief rundown of this and plead the case for something like this appearing in the main source in BabylonJS, depending on the internal group's decisions and community demand. So hope you enjoyed watching this, and this is available at any given time. We'll always keep up to date with the branch of BabylonJS in master. And yeah, take it easy.